What's up, everyone? Welcome back. Patrick here. Moving on to another question dealing with the average rate of change. This one's going to be fairly tricky. A student sent it to me, and I definitely wanted to make a video for it. So what we got to do is provide a quadratic function where the average rate of change on the interval where x is between -1 and 3, that average rate of change is going to be -2. So when I initially got this question, what I tried to do was I tried to find a quadratic function with just trial and error that would satisfy these parameters, and that didn't really get me anywhere. So I highly recommend not going down that route. You could even try it right now. Doing trial and error with this is fairly tricky. It's going to take you a long time to find a quadratic that satisfies this. So what you want to do is you want to have a set algebraic way to do this in case you run into a question like this. That's the first thing I want to mention. Second thing I want to mention is that there's actually an infinite amount of possibilities that you can come up with, right? An infinite amount of quadratic functions that can satisfy this. And I'm going to show you why, at which point you can tell that there's going to be an infinite amount of possibilities when we are doing the question. So to start this off, just as a quick review, if we have a function, f of x, and we're trying to find the average rate of change where x is between a and b, what's the formula for the average rate of change? Well, it's basically going to be the difference between the y values on this function at those x values. So we can rewrite this as f of b minus f of a over the difference in the x value. So we'll have b minus a, like that. You can also do f of a minus f of b over a minus b, right? Same thing. Just make sure that the b and the a are in line over here, right? So that's just in general the average rate of change formula. Now, if we apply it to this particular question, notice that we're given the interval over here. So it's going to be from -1. Actually, you know what? Let's just keep this as a and b, and I'll just label the a over here and then the b over there, right? We're given the interval. And we're told the average rate of change is -2. So what we're going to be finding is this function. And in particular, it has to be a quadratic function. So writing in the parameters with this specific scenario, the average rate of change, we're told it's -2. So this side's going to be -2. The numerator we'll have f of 3 minus f of -1, right? We don't know what this is, what these values are here, because we don't know what the function is. That's what we are finding. So the numerator, we can only leave like this, but then the denominator, notice the b value is 3 minus the a value of -1, like that. So this would give us f of 3 minus f of -1, and then we'll have 3 minus -1, which is like 3 plus 1, which would give us 4, right? And that's equal to -2. So taking this specific scenario, we can simplify it to this. And we can actually simplify this further because even though we don't know what these values are, because we don't know what the function is yet, we know what the whole numerator has to be, because that whole numerator divided by 4 has to give us -2, which means that that numerator has to be -8, right? -8 divided by 4 gives us -2. You can also get that by putting this over 1 and then cross multiplying. 1 times this would give us just that expression. And then 4 times -2 would give us -8, like that, right? This numerator has to be -8 in order for the average rate of change between these x values to be -2. -8 divided by 4 would give us -2. So really, what we've done is we've taken this question and we've simplified it to the point where we need to find a quadratic function that satisfies this over here. Right? As long as we can find that, then we're done the question. So this is the point where I started trying to do trial and error. Like I tried to come up with different quadratic functions. I was like 2x squared, let's say minus 3x, and then I was plugging this in and seeing the difference, any difference that would bring me closer and closer to -8. Highly don't recommend doing that. It's a losing battle. It's going to take you quite a while. So the question is, how can we find a quadratic that satisfies this over here? Well, the first thing you want to do is you want to find values for f of 3 and f of -1 that are going to satisfy this equation over here. And notice that there's an infinite amount. So this is where that infinite amount of possibilities for a quadratic function comes in, right? This is one of the parts that shows there's an infinite amount, because we can use any numbers here. So for example, we can say f of 3 is going to be 0, and then f of -1 would be 8, right? 0 minus 8 would give us that -8. Or we can say, let's say that f of 3 would be 10. Well, then f of -1 would have to be what? 18, right? 10 minus 18 would give us -8, right? Or we can maybe put, like, let's say 5 over here. 5 minus what number would give us -8? Well, it would be 13, right? And we can create possibilities like this an infinite amount of ways. So that's why there's an infinite amount of solutions for this particular question. So let's pick one of these possibilities. I'm going to pick the 10 and 18. Okay, so what we're going to do is we're going to find a quadratic that satisfies f of 3 equaling 10, and then f of -1 equaling 18. Or a quadratic function that contains the points 3 and 10, and then -1 and 18, like that. If we could just find a quadratic that goes through those 2 points, then we're good. We finished the question. Question is, how do we do that? Now, a quadratic in general, what format does it take? In standard form, it's ax squared plus bx plus c. But what's the problem if we try to use this over here, this general format for a quadratic? Well, notice that we'll have 3 unknowns, the a, b, and c, but over here we can only make 2 equations, right? Because we only have these 2 parameters to work with. We don't have a third parameter to work with. So you actually don't want to use this over here. What you want to do is either assume the b value is 0 or the c value is 0. We can't assume that the a value is going to be 0 because that would make it a linear function, and we need it to be a quadratic. So the a value definitely has to stay, but we can get rid of the b value, and the format of the quadratic would be ax squared plus c, or we can get rid of the c value, and then the format of the quadratic would be ax squared plus bx, like that. So this is another step in the question where there's an infinite amount of possibilities. So the first step where there's an infinite amount of possibilities is choosing these 2 numbers that satisfy this. And then the second step is, even after you choose these numbers, you can have a quadratic in this format or in this format, and both of these would be different, but they would still satisfy this, right? So there's a lot of steps where you kind of have to choose your own way to do it. So you can use this, you can use this. I'm actually going to use this. I feel like this one is easier because we won't have to worry about plugging in an x there. That c value is always going to be by itself when we create those 2 equations. So erasing everything here, basically what we're going to be doing is finding a quadratic in this format. So we got to find the a and the c. So notice now, whether we use this or this, we only have 2 unknowns to solve for, the a and the c, or the a and the b. And now we can use those 2 equations. So creating the first equation, we'll have f of 3 equals 10. right? And so plugging in 10 for y, and then 3 for x, we'll have 3 to the power 2, which is 9 times a gives us 9a, and then we'll have the plus c. If we use this, we'd have 10 equals 9a plus 3b, right? So there would be a coefficient in front of that b. But I decided to use this format just because we already have the c by itself. And so that's the first equation that we would use. And then the second equation we can make with this. So we'll have f of negative 1 equals 18. So 18 is the y value. Plug in negative 1 for x. Negative 1 to the power 2 is 1 times a gives us a, and then we'll have plus c. And then that's the second equation. So we got 2 equations and 2 unknowns. And so we're all good to go. So you could do substitution or elimination here. What I'm going to do is I'll isolate for this c value. So we'll have 18 minus a, and then I'll plug in this for this c value. So we'll have 10 equals 9a plus 18 minus a. Right, so bring this over. 10 minus 18 would give us negative 8. Well, this is going to work out nicely, actually. I actually didn't even mean to get here. This was just all on the fly. I actually expected to be working with fractions, but notice, unless I screwed something up here, but I don't think I did. I think everything is all good. Yeah, it looks good to me. So it's nice because notice that that a value we solve for ends up being a nice negative 1. And so the c value is going to be nice as well. I actually didn't expect to work with nice numbers like that, right? If we picked, like, let's say 11 over here and then 19, you'd probably get fractions when you solve here. If we put 11 over here and 19 over here, or any other numbers, most likely, most numbers you're going to pick, you'd actually get fractions. I actually expected to get fractions, but it was nice to get these smooth numbers. And that's it. So we found a quadratic. That's one of the solutions. So basically y equals, we plug in negative 1 for a, so we'll have negative x squared plus the c value of 19. This is an example of a quadratic that satisfies these parameters. And if you have time, you can check your answer. You could check, does f of 3 equal 10? Well, notice if we plug in 3 for x, 3 to the power 2, 9 times negative 1 is negative 9. Negative 9 plus 19 gives us 10. If we plug in negative 1 for x, negative 1 to the power 2 is positive 1 times the negative 1 in front gives us negative 1 plus 19 would give us 18. Right? So you could check your answer. You can redo this question and pretend like it's just a standard average rate of change question saying, find the average rate of change of this quadratic between these two x values. And you should get negative 2. So this is just one of an infinite amount of solutions, right? This is the proper way to do it and not doing that trial and error. Like, to get this, imagine how many different combinations you would have to do in order to get this quadratic. First off, you'd have to know that the b value is 0 to get this, right? That's a crazy assumption to make initially if you're doing trial and error. So again, I highly don't recommend doing trial and error. It's going to take you forever. Do the algebra, take some work, but it's quicker. You get an actual legit solution in a nice mechanical way. And again, this is just one of many. So let's say we picked, like, what did I say before? Like, let's say I picked 2 over here and then 10 over here, right? That would work. 2 minus 10 gives us negative 8. So then this here would be 2, and then this here would be 10. Right? And then we'd get completely different solutions for the a and c. So that would give us another quadratic, but that quadratic would still work for this question. All right? So if you do get a question like this on the test, I think your teacher is just going to look more so at the steps you're doing, or they might just take your final answer and then just test it and see whether it works or not. And then again, another thing I want to mention is that as I mentioned before, it doesn't have to be in this format. We can get a quadratic that's instead in ax squared plus bx format, right? And then we could use that here and then create equations based on this format of a quadratic, right? So again, so many different kinds of possibilities that you can come up with for this kind of question. But if you do get a similar question like this, just get to this point, right? That numerator of the average rate of change has to equal -8 in this particular case. And then just pick two values here that are going to satisfy that difference, being -8, and then have a format for whatever function you're given, right? This could have been any function. In this case, it was a quadratic. Let's say that we were told it's an exponential function. Well, then we can just maybe use like b to the power of x plus c. Whatever format of a function you use, make sure that there are only two unknowns to solve for, right? Because you're only going to have two equations that you can create from that. All right, so as I mentioned, not too easy of a question, right? Lots going on here, lots to take in, but hopefully going through that process makes you understand a little better.